So, good evening, everyone, and thank you for joining our second session for the program How to Start Up. Today's name for the session is Baby Steps. To be honest, yeah, it's an odd name, but I guess we are going to continue taking these baby steps into creating a startup and learning about how to create a startup. And yeah, first of all, I did want to apologize for the rescheduling of the session. Of course, if you're looking at the recording of this session, it doesn't really make a change for you, make a difference. But still, there were reasons, health reasons, why we had to reschedule. And that's why I'm really grateful to all of you who could join here this Wednesday evening. And of course, thank you to all of you who are watching this recording later on. Thank you for tuning in, so to say. And one big thing I want to mention, of course, first of all, is thank you to all of you who have already submitted and created teams. Some of you I had to sort of randomly team up. Those of you who wrote to me and told me that you don't have an idea or you don't see an idea you'd like to join in with. So thank you to all of you. As you probably, those of you who are on Slack, noticed that I shared this Google Sheets file where I've written down all of the teams, the ideas, the participants in each team. So if you haven't yet noticed that, I shared it in the homework channel. And if you can, please go over that one if you have submitted the team. Just to make sure that the correct team members are there, the idea name and the description is correct, and so on and so forth. But of course, as it's happened, I see that 71, I think 72 participants have joined in teams that I have written down in that Google Sheets file. So I will give you the opportunity to still come up with teams up until this Friday, end of Friday, let's say 6 o'clock on Friday. Just so, because if you want to finish this program, if you want to receive a certificate for completing it, you do need to participate in these teamworks. You do need to be in a team, and you do need to develop an idea, whether the idea is actually feasible, something you've been dreaming about, or whether it's something completely ridiculous that you just came up with on the spot. That is completely okay. We are here for the experience and the learning purpose. But you do need to be in a team in order to finish this course. So yeah, please, by Friday, if you haven't yet, you still have time, still continue using the team formation channel. If you don't have a team or an idea, write to me a direct message. I will team you up with someone. I will create this random channel. I will throw you all together. And well, then your task is going to be to decide what the hell are you going to be working on. But yeah, so please continue teaming up. And of course, the more you prolong it, the harder it's going to become, because after today, we will already have the next homework. So you kind of need to be in a team to complete it. But yeah, regarding the lecture, first of all, of course, feel free to ask questions later on, whether it's verbally by unmuting yourselves or by typing the questions into the chat, just like the previous times. And today we are going to talk about design thinking, about idea validation, and about going from prototype to MVP. But I'm not going to be the speaker, so Kaspar's today's speaker. He's going to go a bit more into details about that. And today it's going to be slightly different in the sense that the presentation, it's not going to be longer, let's say, than 30-40 minutes. We will see how that goes. And then we will, I would call it quick fireside chat. I will ask some questions to our our lecturer today regarding the topics that we're supposed to be here, that we are supposed to cover today. And after that fireside chat, we are going to have a sort of a free-for-all where we can have a Q&A with Kaspars, and you can ask all your burning questions regarding the topics that we are covering today. So without further ado, I would like to welcome and give the floor over to our today's lecturer, Kaspars Kalvish, product designer, founder of Zello Fenders, and tech mentor at Build It Accelerator. Kaspars, the floor is yours.
Thank you, Pauls. Good evening, everyone. As I heard, some of us are doing great. That's good to hear. I'm also doing okay. So briefly about me and today's lecture. This is all very much impromptu for me, since the previous lecturer kind of, we heard medical issue of some sort. So pardon my maybe at times chaotic approach to today's topics. My background is in engineering, so I'm going to be kind of tech heavy on this design questions, and but I'm going to go through examples of products that I've been involved in developing and designing, just to kind of address these topics with an example, and maybe kind of emphasize what not to do and what could have been done differently to maybe get a better outcome. I've been in startup scene for more than 15 years. I mean, before the word startup even came to Latvia, we started with some web page based projects, and slowly I kind of moved on to hardware. So again, this is to dig a bit deeper. It's going to be quite hardware heavy. These are essentially all going to be hardware products. By hardware, I mean an actual physical electromechanical high-tech device, or just mechanical. Again, that's not the main distinction, as opposed to what hardware means for electronics guys. It just means electronics. So in this case, it's a bit broader. It's a full set of a hardware product. Now, for those of you, of course, who are not developing a hardware idea, some of the topics might be a bit less relevant, but overall, the overarching approach in terms of understanding your own product, coming up with features, validating them, is going to be pretty much relevant. A little bit more on the background. I've been a part of product design company 1012 in Estonia for about 5 years. So this kind of has given me the opportunity to be a part of or near a few dozen products in the whole stage, from idea all the way up to actual production. So one more emphasis that I would like to put on in today's talk is on scalability, which is not a big problem in software. Obviously, scalability in software is very straightforward. Whereas in hardware, this is, in my opinion, one of the biggest questions to solve. And you have to start solving it already in the very, very early stage. As you are ideating on what features you're going to have, you always have to keep in mind what are going to be the ways for you to actually produce it. Yeah, so I probably would like to run through today's topics briefly, give a short comment on each one of them, since it's possible that I might not address some of them in depth. So just at least I would have said some of my thoughts on them. So the problem solution question was the first one. So finding and defining the problem is going to be a part of one of the examples, in fact. But in my opinion, the best way to find a problem is not to look for a problem, but to have the problem find you. That is to say, when you are passionate about something, you do it a lot, and you probably notice what are the suboptimal features of it or problems with it. And once you identify a problem like that, that's probably the problem you should see if you can solve. Mainly because, well, there's probably two big reasons why this should be the correct approach. One is because you're going to be spending hundreds or maybe thousands of hours developing this solution. So you better be passionate about this question. And the other one, of course, is that you'll do better if you understand who this is for, if you feel like this is essentially something for you as well. So these are kind of the two big criteria by which I would start when finding a problem. So yeah, the design thinking part. The design, this word, it's a very, very broad word, and in my understanding, what it actually means to create. So in other words, this is some kind of a creative process. Of course, there are many theories and thoughts behind it. I'm going to essentially talk about these examples that I will present. So we'll see the design thinking in those cases. I'm probably not gonna go any more into, say, theory of this thing. And the topic of product market fit is going to be the one that I'm going to talk the least about, since again, I am an engineer. I'm going to be more focusing on feasibility, in some sense, business viability, where it concerns choosing features based on business considerations. So yeah, maybe some product market fit questions will arise in the examples, but yeah, don't count on it too much. Then the question of going from prototype to MVP, surely it's going to be one of the big ones in my examples and my approach. I will, of course, also address the question of prototype, which is one of the big keywords I don't like, and I will explain why. And yeah, we'll go further than MVP. We'll talk even about production and scale. And then the validation questions. Again, more probably validation on technical side. I will address again through the examples, less of the market size side, but yeah, let's maybe dig in. Let me share the little presentation. Is it on?
Yes, so we can see it.
Okay, yeah. So during my time in product development, let's say community, I've worked on probably more than a dozen products in depth. So let's take a look at some of them, and essentially, probably we will focus on what could have been done better. Yes. So Ample was actually one of the first products we started with my good friend Viestur Sosars, probably a guy you are all familiar with from previous presentation. It was a case for iPad that gave you a superior sound. This was done in the 2016. It was a time when, no, that was the assumption. The sound of iPads was a big problem, so we were trying to solve that. It obviously added some bulk to the iPad itself. Did add a nice bass, but some of the problems we ran into were, first of all, this wasn't really a product for us. As I mentioned before, the passion part was what was missing. We were not making it for ourselves, so we didn't really understand the market. We didn't understand who we were making it for. And even though, technically speaking, we got it done even further than just the MVP, it was done pretty much all the way up to design for manufacturing, to a point where we were in talks with a Chinese manufacturer to produce it. I would like to also emphasize that there is, it seems, a common, let's not say misconception, but common understanding, especially in hardware startup scene, that that's how it's done. You make a design and then you go to China and then the Chinese people produce it for you. This is, in my opinion, and by my experience, one of the worst ways to go about it for a startup. Tell you why. Mainly because in the beginning, in early stages, for a first product, you're going to be running into all kinds of questions and problems you're going to have to solve. And it's far easier to solve them when you are near your production partners. So for anyone who starts out, I would always recommend, don't go far. You will definitely always be able to find a production partner near you, someone who you can talk to in your own language, therefore eliminating lost in translation, miscommunication problems. And you will benefit greatly from being able to go there on site and adjusting, helping the producer optimize everything. So the other problem for this particular product was that, and this is something you should always kind of keep in mind, don't solve a problem that can easily be solved by the big boys. So in this case, we were trying to solve a problem for iPads, and in the next generation iPad had solved it already. So the product had essentially lost its purpose. So probably kind of have to make sure that you don't put all your eggs in one basket type of a thing. And the other problem with these hard enclosures is the fact that there's so many different size products out there. So we would have to design one for each one of them. And this, of course, becomes non-viable in terms of, say, tooling that you would need to create all these different size products. So again, something to kind of consider. I guess this is to tell consider what your design choices are gonna cost you in, say, startup costs. So in this case, injection molding, tooling, which is a very expensive thing. So yeah. So then I would like to talk about some products whose names I rather not tell because of NDA considerations and because of the facts that I'm going to be talking again about things that might have been done better. So there was this interesting product, which was a crypto wallet we developed. And the mistake, I believe, that they made was that they had decided right from the get-go what the design was going to be like. They were really particular about it. They would not budge. They would just want to stick with this particular design. Now, no matter what you think of the design, it does put you in a very constrained place when it comes to choosing and understanding, choosing manufacturing technology. And I mean, all the other requirements still come on top. So you become super constrained all the way to a point where it might even stop being viable. You might not be able to fill all the other requirements. So when you design a product, you should, in my opinion, you should always allow the design to flow and change around utility at first. That's probably my bias, the utility, and your visual preference second, and probably even ergonomics are even before that too. So visual would probably be even third in that sense. So in this case, we were pushed into very badly scalable technologies such as machining, which was, first of all, expensive. Second of all, it only scales linearly. So each product would have cost a lot of money. On its own, this is not necessarily wrong to make a product that requires machining. In the end, it matters what is the price bracket you're aiming for. So all these things can make sense. This is a business viability question. You must define and understand if the price point you are aiming for is something that has a viable business behind it. This, of course, is where evaluating your potential customer comes into play, as in other things that we're going to be addressing further. But this is this is one thing you should definitely test in early stages. I'm going to probably talk a bit more in detail about it later on. Let's run through these examples. So another product that we developed was this controller that you wear on your feet to control your movement in virtual reality gaming. Overall, it was not a bad idea. You sit on a chair and you sort of walk, and you can pivot around on the chair, so you kind of get more or less realistic experience in the virtual reality. A couple of issues that they had, and one of them, in my opinion, is that you must, in early stages, you must make assumptions about the particular way you will solve something, and you must test it. Not always, but sometimes when you assume that it's going to work this way, but it's a more complex, say, system, it would be much better if you tested it and retested it until you're sure that this is the most optimal solution. And you must also test it by keeping in mind the technology in which you're going to produce it, because there's going to be all kinds of potential little differences or tolerance issues that you have to understand. In this case, the probable mistake was that they went for a mechanical motion detection system, which in the end turned out to be not give such a high quality as potentially just electronic one could have, and added to the price of making the product. So yeah, in other words, investing early is usually the wisest choice, even though early on you might have the least money. But if you would understand how much investing time into developing something and then putting it into production will cost you extra, and then you discover the problem, that's of course a far bigger problem. I mean, in the end, this could mean the end of the project. So the beginning is really, really important. And in case of physical objects, I really recommend that you put in a lot of effort and time into understanding that all your assumptions work. This is where, in fact, the prototyping comes in. This is one of the main uses, in my opinion, for prototypes, is to validate if the idea works, it actually can do what you want it to do. And yeah, and then the other thing, which is kind of, I think I notice a lot for hardware startups, is that they usually want to optimize the tooling for price. So you would go to a potential producer and you would evaluate him for the price that he quotes you on, say, producing your parts. This is not really the best approach. Again, in the case of this particular product, what happened was they optimized for the price so much that what came out was of a quality that was not really something they expected. And this is generally the case. Low cost tooling is going to give you low quality parts. And you will see it, and there will be many kinds of visual issues, all the way up to warping, where part is essentially unusable. So in other words, dimensionality problems. So if you are aiming for high-end product, I suggest strongly that you also understand and go for high-end tooling. So if you invest much more, you risk much less. This is where, in fact, one of the approaches that in 10-12 development we do early on, one of the first steps that we do is we make this cost-benefit analysis, risk analysis, where we try to make a list of all the potential risks that a product has and their impact on the business itself. So what if this fails? So what's going to happen? Or what is the likelihood that it's going to fail? And when you do this, this really helps then in eliminating features and choosing production methods and techniques. And this should be done early on, really, to kind of understand if you're not putting yourself in a bad position. Yeah, so another product that we worked on was a smart socket. I mean, it's a design product. It was made for high-end market. The only problem it had was that the problem it was solving was so ununderstandable. Perhaps it was a problem that maybe few people had, and the product owner was convinced for a long time, and he really went all in, and we got all the way up to production. And in the end, as far as I know, I don't know if that was the end, but in the end that I know, he couldn't really sell almost any of them. And I mean, so yeah, you really have to make sure, again, this comes back to the market validation, is to understand if this is really an actual problem you're solving. In this case, I think it was some fire safety features that he was going for. And last but not least, my current product. In fact, it's a product I've been working on and off for 7 years. It is a purely mechanical product. It is a mudguard or a fender for bicycle. And it's kind of a revolutionary one, in my opinion. It's a good looking one. I mean, if you look at it, you probably don't even see it on the bike, which is, I think, what the fender should always look like. It should not be there. It should just do its job. So why I would like to point this one out, it is because a good idea probably means something like this. There is this idea of red ocean and blue ocean. So some would say that essentially all the products are in red ocean, meaning where everyone else is. So you're competing with everyone else with a similar product for whatever market is there. And the blue ocean would be a place where there's no competition, but likely there's also no market. And a good product is somewhere like in the middle. Because the border, of course, is not black and white or blue and red, but it's somewhere in the middle where you should probably see if you can get in. So it should be a product that has some kind of a innovative enough feature that you validate, say by customer by methods that I will describe later. But anyway, so something you would validate that comes out to really be a good feature that makes you special enough that you are not right in the middle of the red ocean. So in other words, you might have some natural sales, because what I've also heard lately, especially, is that back in the day, like 5 years ago, you could still sell directly, say through Facebook ads or something like that. But now it has become so expensive that it's very difficult to fight there. So having a natural kind of a that special something is important. And the other thing is that it would be good. Again, I'm merely giving you very vague, kind of broad characteristics that a product might have, which would be good. It would be good if this product had some kind of a natural protection from being copied. In other words, of course, there is a patent as an instrument, but first of all, obviously, for a startup, patent is very difficult to acquire. I mean, there's so many markets you would acquire it for, and I mean, surely it's in my opinion, it's not a good tool for a startup. For a startup, a better tool would be if there was some knowledge that was hard to come by, say, that protected your product. Or so in this case, in my product case, it's the way it's made is very difficult to copy. The technology is not easy to do. Oh wow! So bite size, interesting. Oh yeah, okay. So yeah. Also, it is very important to have a team that covers essentially the playing field for you. So you would be able to get things done without, say, a lot of investment. Especially, I would say, in hardware, this is important to have your tech side, tech expertise, and your business side. Well, whereas in my case, I only have the tech side, and I'm building the whole thing alone. So probably a suboptimal approach, and I would not recommend this to happen. So a lesson learned, by the way, in this case, is that if you are a tech savvy person yourself, makes sense that you don't develop your idea alone, because once you've done it enough, it becomes very difficult for you psychologically to get a co-founder, because you feel like you've done so much and the co-founder hasn't done anything. So it's a psychological barrier that's difficult to get over. Better to start things with other co-founders that supplement your strong sides with their strong sides. Yeah, so let's maybe kind of pull this all together. This is where it might get a bit chaotic, because this is now the part of a presentation that I kind of tried to adjust for today, which wasn't really made for today, so bear with me. So the initial stage, when you start to develop your idea, usually what happens is people start having all these features around it. They start to imagine this and that, and it could do this and that. Definitely for MVP, especially if it's your first product and you're not a company that's already running and has traction, you should trim it down to the very, very basic thing you can possibly. And to do it, again, you would talk to your potential customer. You would talk to the customer probably by giving them prototypes if it's a physical product, or even prototypes if it's a software thing. Obviously, you can still do it, and you would observe them. You would have some questionnaires. You would try and understand how they would use it, what features they would like, without actually emphasizing them or asking them directly. You just really kind of let them play with the thing and understand what it is that they would like. You should always understand and kind of remember that liking something and paying for it are two different things. I mean, especially if you talk to your friends, I mean, you're probably going to get a lot of positive feedback about your product. You have to be critical. You have to think of this. You have to take it with a grain of salt. You have to really understand that it might not be so. So this is unfortunately something that where all the techniques I can't tell you. I'm not that good, but I can tell you that some of them, which is again putting the object into people's hands and looking at how they interact with it and trying to understand what they would maybe be willing to pay for it is also kind of important. Also here, obviously, how you would select the features would depend on the feasibility in terms of how you can actually make it. So this goes for hardware and for software as well. For software, you could probably make everything. It's slightly different in that sense. Whereas in hardware, every new feature you would add would hurt your scalability a lot. Because say something simple you can make in one technique, in one manufacturing technique, but if you add more, you might not be able to. So you now have to go say into machining, which is expensive or whatnot. So these questions you would have to understand, and to understand them, it is probably enough at first to just read, just Google about these techniques, understand at least the basics of them to give you that framework, that kind of landscape overview in which you're operating when you are deciding on what features to have, what features not to have. Yeah, so let's see what else I have. Oh yeah, my favorite prototype question. So in Latvia especially, I've noticed that people in hardware, they would be creating prototypes. Like that's kind of the thing that they do, but it's really never the thing that you do. A prototype is a certain little step in the development or design process. It is something that you use as use for certain purpose. So you're never actually just creating a prototype. A prototype is just one step. So what would you use it for? As I have kind of touched upon before, the idea validation is one use of a prototype. So you would create something that you have assumed would be needed, and you test it with users usually. So at least with some users, it doesn't have to be a lot of users in the beginning, just have some. So the other way, the other purpose of a prototype is, as I also mentioned, is the validation of the technical solution. And today, in fact, for hardware, it's sort of easy, especially if it's smaller hardware. I mean, there's all kinds of techniques and available technologies that can be used. There's always a little bit problematic when it comes to, say, talking to somebody else to produce it for you, because usually companies that produce stuff, they don't like one-offs, they don't like prototypes. It's always kind of a fight. So you actually have to be ready that if you are in a hardware startup, that working with all your potential producers is going to be difficult, and you have to really work through it and have to push them to help you or to do something for you. This is one of the points that hurt a lot of the startups, because they are not pushy enough. I mean, this is unfortunately the case. No one who builds stuff cares to build one-offs. They care to build batches of stuff. So yeah, prototyping, therefore, 3D printing is a really good thing you can have these days, for example, as a easy tech to be used for prototyping. For software, of course, again, not a specialist, but if it's an app, of course, you can build something, a thing, and test that. So another use for a prototype is for demonstration purposes. And this is usually when it comes to raising money. So you would use a prototype when you go and talk to investors. So in this case, it's possibly just a visual prototype, let's say not a functional one. So you would talk about the features, or you would, that's kind of the idea. And the very kind of last point for a prototype would be a certification process. Usually certification for hardware is done on an almost finished product, but you can get the ball rolling, so to speak, with with a prototype that's, say, using a lot of the produced parts already. It's usually the process actually is that if a product has many parts, then they all don't come in at the same time, of course, because they have different, say, producers and all that. So you might be able to put mostly produced prototype and start the certification process. But of course, underneath it all, when it comes to designing, and again, this applies for the hardware, is to design for manufacturing and assembly. So you always at least have to have a basic idea of what it's going to mean to scale this, what technology you're going to use to make this thing in scale. And you should always have your production partners actually already kind of with you along this whole development process. So you would identify them early on, approach them, start conversation. Whoever talks to you, you go in deeper and you start to build this relationship. Because again, it will be difficult in the beginning. For startups, it's always very difficult. The first question is how many thousands of this you need, and you usually don't need more than 5. So you build these relationships right from the beginning, and they help you also in the design phase, in that they would give you feedback on what they are capable of doing and in which ways, what's more efficient, and so on. This is, in fact, where I think one of the bigger, well, let's not call it a misconception, but one of understandings of production or misunderstanding, well, okay, I'll call it a misunderstanding, it's that a lot of hardware tech startups think that you come up with a general idea, maybe with a visual design, and then you give it to some mystical producer, again, let's say in China, and things start rolling off a conveyor. There is only one situation where this is the case. I will come back to that, but more often than not, if you are creating a product that has really some added value added by you, some kind of innovative feature or some kind of a proprietary solution, you will be the one who will have to design it in detail. So you don't just give it to someone. Essentially, you would be getting a cat in a bag kind of a deal, and you would have no control over anything, not the quality, not the features, nothing. So for an actual high added value product, you would have to do, either you would have to do it or have somebody close to you, say a development company, do it for you along with you. Whereas say a producer, and this doesn't only apply to Chinese producers, this would go for any production partner. They rarely, but sometimes they do some adjustment to your design to kind of make it more suitable for their capability. Sometimes they even promise to do some more detailed design, but again, this is usually not what they do. So you would have to come with ready-made production files to a company, which means that the idea designed for manufacturing kind of have to be within you all the way through from the beginning to the end. So you always have to consider how it's going to be produced. Yeah. I guess I'm actually getting close to the end of it. I think this just a little overview. Let's recap. So initial idea should be kind of developed to a point where it really has become kind of simple in terms of a message, because this is going to help you with marketing and sales. It should be something that you have identified as a good problem and a good solution to it. Again, these are very vague terms, but yeah, this kind of has to come, I think, in a nice, elegant, simple package, where the problem could still be complex, but all the complexity is hidden in those countless hours of development you put into the object or product in general. Yeah, you should, in hardware, this is particularly in hardware, you should always have your partners, production partners near you at all times, like from the very beginning, because their feedback and their expertise is going to be very important, and the fact that you have built a relationship with them is also going to be important. maybe the other ones are not necessarily that relevant. I guess so. I guess that's that.
Okay, perfect. Then I guess we can go on. Thank you, first of all, Kaspars. And I think we can go to the questions part. I see that already we have a couple of questions in the chat, but as I mentioned previously, we will get to the Q&A part a bit later on, because there are a couple of questions I have already prepared that I'd like to ask you, Kaspars, before we move on to the Q&A part. One thing though that I wanted to mention, you said now at the end that you said especially for hardware, you should have your production partners near you. And I agree about the hardware, definitely, but I would like to put in here that this applies also to the software. I mean, you can use Fiverr or other platforms to outsource specific tasks, or even outsource building your app or website or whatever. But it will always be easier if it's near you, and also probably if it's in-house. So what you mentioned about China, producing some hardware thingy thing out in China might not be the best way to go about it. Same applies for software. I would say that it can sometimes be better to do it in-house because you have more control over what the hell is happening there, what's being done.
Yeah, I wanted to add to this. Actually, I forgot to mention, there is a case where it might make sense to, say, have a Chinese partner, or maybe also as an equivalent in software world to have it outsourced is, but in hardware definitely would be the case. If you actually are just a manager who would like to, say, sell something, and you could just essentially white label a product that is there, which is in fact what a lot of people do, which is definitely not the same as hardware development, but sometimes you can actually have some minor changes to it. So I've seen some companies kind of try to start out that way, where they would have a white labeled product, kind of build up their name, and then slowly try to add some proprietary thing. So it could be an approach. Again, if you are business side heavy in your team, then maybe this is the way. You really want to go into hardware, which is, I probably wouldn't suggest if you don't have tech expertise. Just makes zero sense to me to do it like that. But again, this could be the way then. And by near, in fact, I don't necessarily mean physically near, which I also mean, but I mean near in terms of just being there to answer your questions as you move along. So yeah, that's even before you get into production.
Okay, thank you. So a couple of questions, like I said at the beginning and just now, I have already prepared regarding today's topics. And one thing I wanted to touch upon was ideation, considering that a lot of teams, a lot of participants of this course, some of them have already sort of ready ideas, possibly even MVPs, but a lot of you that are participating don't yet have finished ideas, and you're still in the phase of kind of thinking about what to do. So one thing I wanted to ask you, Kaspars, from your experience, what are the best ways for ideation? What would you say?
Yeah, I mean, again, mostly applies to hardware, but I'm pretty sure this would apply to software as well. The way we did in 10-12 is that when a new project comes in, provided that the product owner hasn't already strictly defined, but usually this would anyway happen. We have a workshop, which is precisely that. We all come together, we understand what the definition of a product roughly is, and then we all get certain time to come up with, say, 3 potential solutions for one part of it, let's say. Or maybe we take it broader. I mean, it depends, it's product by product. Essentially, you would have a team come together, not even only those who will be involved. I mean, in our case, it's of course a design company, so we have more people than are per each project. In the startup case, of course, maybe it's just you, but it wouldn't hurt actually having in somebody else just for the session. Someone from, I don't know, a friend who's in the industry, or someone who has done something similar, or an engineer in general, or who else, and then organize it this way, where you have a definition of a problem, and you all come up with, say, 3 potential solutions. You draw them out, then you present them to the rest, or you just collect them all together. And yeah, I mean, slowly this way, everyone kind of chips in, and then whoever is then in charge takes this whole thing and tries to make the best choices, let's say, and put it all together. That's yeah, that's how we've done it.
Okay, and so basically you've come up with some sort of idea by putting this together. What would be the best ways for defining the idea now that you've gone through the ideation phase? What's the next step? How to define it best?
Well, I mean, I would imagine that you mean defining the idea before ideation step or after it?
I would say after, like, you've gone through the brainstorming, you've come up, but now you need to pin down the details and.
Well, I mean, this is kind of the bread and butter of engineering world. I mean, you just start engineering it. So you take the vague ideas and you start putting in detailed work in it. I guess if you mean how you say choose the best solutions, let's say, or yeah, let's call them best ideas. Again, I would say this is a more or less technical thing when it comes to choosing them from a technical perspective. Obviously, you would, depending on what the product is, you would maybe try and create some kind of a testing rig, be it a prototype, be it maybe a questionnaire or something, where you maybe would bounce this of some potential users. Maybe this is also possible, although the kind of ideation I was more talking about is already when you are talking about actual solutions, which are well, they're still somewhat related to a customer feedback, of course, but this is already kind of a bit later on. So before you even get to this type of ideation, you would probably already have identified this very broad idea, would say some people who would have at least tried to understand if there is this problem, and what do you think of this solution that I can put in 5 words, without actually having any kind of real solution. So we would just bounce that off of some people and understand if this is even kind of a direction in which you should dig deeper.
So regarding this already sounds like you're talking about idea validation in a sense, and there was the next question I have written down. From your experience, what would be the best ways to validate assumptions about an idea? No matter be it software, hardware, but could you name a couple of ways? Like, yes, interviews, shoving the physical prototype thingy in the hand of a person to touch it, be it a paper model of it. What would you name are the best ways to validate these assumptions of an idea?
Yeah, again, would be case by case, and obviously those kind of are, I would say, the big ways to do it is to really kind of so again, there's 2 sides at least, which is market side and technical feasibility side. So obviously each one of these you address in different ways. So for example, you might maybe have to go into some testing lab to test out some features, for example. So you would build a rig and you test whatever your solution is. And if it's, say, a crucial feature, you would also, this is where the risk analysis kind of comes into play. If you have already worked it out in the beginning, you understand which points are very, very important for you to really make sure you got right. And you should probably in early stage kind of update this risk analysis as you move along and as you kind of test the most crucial, deal-breaking kind of risks. So again, from technical perspective, you would say do lab tests, or in other words, when you're building a product that has some innovative feature, which is the only kind of product I would say you should ever develop, you would have what I call the lab stage before you actually start, talking about the design. I mean, you would be thinking about design obviously in the lab stage as well, but that's purely functional place where you really make sure that whatever is the idea works and that it works in the way that you think it should work. So it's it's where the technology readiness level kind of comes into play. In my opinion, the design, or let's say the design in visual sense, kind of begins after TRL level 9. So once you have proven and done the technology, it's there, it works, at least in some one-off, it's done. So yeah, that's when the design stage begins, as I was, that was the one I was addressing mainly during my speech. So after the TRL 9.
Okay, thank you. During your answer, and you also touched upon the risk analysis during your talk as well. But regarding the risk analysis, if, let's say, in the audience we have people that haven't done it before, how should we go about it? What are the first steps to take? What are the correct questions to ask? What are the wrong answers to receive, and so on and so forth?
Yeah, I guess you just have to be very reasonable and logical. You have the idea of an object or a product, let's say, in your head, and you start thinking of all the ways that it can go wrong. Let's say in mechanical sense, what can break, what effect that would have on a user, or in software sense. I mean, you can always say speculate on what if this feature died, how bitter would that make the user feel? Would he ditch the product, or how likely it is that it would happen? I mean, really, there is no recipe in that sense. It's just say logic, and you as the team coming together and really kind of throwing out there even the silliest ideas. I mean, they will have the lowest risks, say lowest impact and lowest likelihood, and you can just disregard them in the end. But it's a good idea to really throw out all the stupidest ways you can imagine that the thing, or the process of using the thing could go wrong, and what impact that would have. I mean, in the physical world, surely the biggest problems that you might have in terms of, say, usage would be some injury that could occur. Obviously, you have to address potentially injurious failures as high-risk problems, right? So in software, again, I mean, I would imagine that, you have a feature that a person, just ditches you if it doesn't get it working or something. So yeah, I guess it's case by case. I hope I have kind of given the broad overview.
Yeah, thank you. And the final question I have prepared, and then we will move on to the Q&A part. And I see that, really, we have quite a few questions already prepared. So you mentioned about regarding, I already forgot the name of the product, but that was about the iPad and its case, and that you weren't passionate about it. So you yourselves, you and Viestus, were in the target audience here. And so that's the one thing, how to sort of define the target audience, that you yourselves, you were passionate. We are, I don't know, this age doing this, and that's why we're interested in this. So what would be the best way to define the audience or the perfect customer, apart from being passionate?
Again, probably, especially given the experience with Ample, and as an engineer, I did not like it. It was a good challenge, technically speaking, but again, I wasn't doing it for me. So yeah, you do lose a lot of that. The passion is good. The passion drives you. Passion, you would really enjoy those thousands of hours that you spend on it. So surely there's techniques how to define an audience, but I would strongly suggest that you don't just go around looking for ideas that don't matter to you or don't interest you. So I guess I guess I won't give a different answer for this. So just find problems in your everyday things that you like to do and solve them.
Okay, perfect. Thank you. So I guess now it's time to move on to the Q&A part. How would you like to go about that? Do you read the questions yourself, or should I read them and you just answer?
I guess maybe you read them. I mean, let's make it a dialogue.
So the first question was asked by Arturs, and it was, at what phase moment do you discover these issues that stop the further development? You were talking about I think it was about the VR thing.
If I may add myself,
Yes, please.
the question was more or less related to all the projects that you presented. It wasn't clear if they were continued or at what phase they were stopped, and then why. You mentioned some of the reasons why, but more like how did you actually come up to that it's problematic?
Yeah. So
or stops the further development. Yeah. Thank you.
So the desirable stage at which to understand that something's wrong is, of course, the very, very early stage before any before rubber has met the road, before any money has been spent on physical things, on tooling or anything like that. So obviously, this is the thing that for hardware especially you have to be really mindful of, and it's difficult to be mindful of it when you're doing your first product because you really you haven't been there. You don't know all the things that it can go wrong, of course. So it would be best if you tried to educate yourself about all the potential topics. Again, this is much easier said than done. So of course, there will be problems. Usually, you would solve them by having some spare money that you kind of accounted for. You thought that, okay, this is in case something goes wrong. So you have some budget for some small failures. But for startups, especially where the biggest failure usually seems to be, is in when the sales start. I mean, you can solve all the problems of making the thing. I mean, sometimes the problems are pretty harsh and hard to solve, like the prototype, the product you were talking about, for example, the one where potentially wrong solution was employed, and this was pointed out to the product owner as well, but they said, yeah, let's go ahead with it. Well, yeah, so hopefully you have enough money to then go and redesign the thing and then say change the molding if you can. So, but what breaks the product mostly is when the sales start, and this kind of would mean that you have not identified, say, well, maybe the target audience, or maybe the solution isn't that good, maybe price point is wrong. And these are all the questions that ideally you could answer in the beginning, and you should do your best to do it. I don't have this right answer, you know. I mean, case by case, I would do my best to try and assess all these questions and address them to the best of my ability. But obviously, the end of any project development cycle, you will have some moments that you would say, okay, I should have done it like that, not like this. And I mean, the hindsight will always illuminate these potentially different paths you could have taken. So you can only hope that you've done it the best you can, and that the best you can actually was good enough. I don't know. Did I get to answer it to some degree? I mean,
Atos is waving yes. Okay, let's move on to the next question. This is regarding Zello offenders, and maybe not regarding the theory, but your personal life and your views and your aspirations. So, do you plan on exiting with Zello offenders?
Yeah, I guess this comes down to what I would have to say about the startup mindset and hardware. I mean, when you're in software, then you can be a true startup in the sense that a startup is essentially a company that has this high growth aspirations. In a hardware, you don't actually expect to become a unicorn. The scalability constraints will probably prevent you from doing that. I mean, to become an Apple, company, you would need decades of successful product lines. So in other words, it's of course a different scale. Surely there is an option of exit, because what I have noticed lately, big companies invest less in R&D themselves, but buy out smaller companies that come up with some innovation. So in other words, exit is kind of always there as an option. I think it should always be as an option for any startupper and anyone who's in tech in general. Not the main option, but surely an option. But since this is also my passion project, then of course I would probably like to just work on it to the day I die, I guess.
Thank you. Next question, also from Jans. Regarding adding new features to a design product, you were talking about that during your presentation. Isn't it so if you add new feature, you should add to the price as well?
So obviously we're now talking about hardware, I would imagine, because for software, obviously you can always add new features as you go, so that's not a problem. Yeah, so I guess what this question kind of boils down to is how the price is made. Where does the price come from? It used to be back in the day when essentially you created products and then sold them through retail chains. There was kind of a rule of thumb, cost of the bill of materials, or let's say cost of production in general versus what the retail price is. So you were kind of usually driven by that. You knew that you had to produce it at something like 25% of what the retail and end user price is going to be. Later on, when direct sales kind of became a thing, of course, the margin structure changed. You could have a far lesser margin. I think, so the short answer is, of course, if you add features, it adds to your costs, so it adds to the price. Does it add to the value perceived is, of course, the question you solve in the early stages when you evaluate what features need to be there. But I usually like to say to startups, especially, is start with a simple thing, make it work, make it generate traction, and then have a generation 2 product, or have a different product in your line or whatnot that then, you know, has that additional something on top. Because in the beginning, especially, it will be very, very difficult to have a lot of features on a product. So start really with a simple thing that really solves the issue.
Thank you. The next question, once more from Matos. How do you draw a line between mockup and a prototype when a prototype should have all components and features that end product should have? And how far do you see okay to have a working mockup for testing? Personally, the final sentence, Arturs, maybe you can elaborate on that, or Kaspars, did you understand the question?
Well, let me start maybe answering it, and then if there's some more you would like to add, we can we'll take it from there. So mock-up and a prototype, I don't think there is a necessarily big difference when it comes to, say, prototype that is for visual use, for example. So that would maybe be a mock-up as well. Again, as I say, prototype is a far less important keyword in the process, but it is something that you do for a certain purpose. So a visual prototype doesn't have to have any parts in it. It doesn't have to have any functionality. I mean, its purpose is to demonstrate the idea, say, for example. Maybe it's, you know, you haven't done any detailed design, any development yet. You're merely looking for investment, let's say, or just, you know, bouncing this idea around with, you know, potential end users. So in that sense, you wouldn't have any components in it. When you would need to start having components in a prototype is when you're testing certain, let's say, functionalities of it. So then you make a prototype for testing functionalities. Then you do, you know, whatever is appropriate for the particular product. You do maybe lab tests, which is you actually, let's say, go to in universities, you can find labs that will do some testing for you, for example, or you maybe do your own testing. So yeah, as I had in my presentation, there's essentially 4 main reasons for prototypes, and each one of these reasons will dictate how sophisticated and how representative of the actual product it is. So, and what's the last part? So would you like to elaborate on the last part? How far can mockup work for?
So basically, from my understanding, mockup is something that you do basically until you start the, so to say, mass production, and the prototype is like a first before the so to say mass production, where you actually use the all correct materials, use all the necessary visuals. In this matter, basically, at what moment do you see it's needed to switch from 3D printing your own mock-ups / prototypes to actually going out to some producers and try to make it more.
Yeah, so this kind of goes in line with the whole idea of design for manufacturing as a base thought at all times, starting from early on. So in other words, you always think about the produced article at the end, what technology is going to be used to produce it. So and you always, throughout this whole process, have production partners, potential production partners near you. So it will become apparent at one point. I mean, again, it will be a question of how you use the prototype. I mean, at one point, some parts will start coming in from the producer. Let's say soon, close to the point where you will start shipping out. You will have, most of the parts. And how it usually works, at least in the region, is that the final step, the assembly of the thing, is done. Usually, it's an electromechanical device. It's done at the electronics manufacturer facility. Usually, they produce the electronics components. They put it all together, do the testing, do the packaging, and then you can take it from there. So in other words, if I understand correctly, then I hope I'm kind of giving you the alternative view on it, because it's always the fact that the produced parts will kind of, yeah. Okay, it's so when the question is put this way, it's difficult to answer. I think that the problem is that prototype is only used for a particular purpose. So again, how long you will use it depends on how long the purpose remains. And all along in this process, some producers somewhere near you, and you can't just take your prototype and go to a producer and have it produced. This will be a pretty long relationship that you will be building with a particular producer. I hope I'm kind of.
And in relation to finding investment and start to work on sales or expanding the research resources, it's okay to use own made 3D printed.
Yeah. I mean, actually, this is today. This almost is a way to start, especially if your product requires some expensive tooling in the beginning, and if it's small enough that it makes sense to 3D print it. It's in fact the way a lot of startups do start. They have at least some parts printed, and then slowly, buy in tooling. So yeah, I mean, it is today when 3D technology is available at reasonable price, it's business viable for many products. So yes, definitely you can start with that. I wouldn't call it a prototype. I'd call it small batch production. You can you can use that, or you can use silicon molding for dozens of items. Again, whatever gets the ball rolling. In this case, yeah, it's usable like that.
Okay, thanks.
Thank you. I see that in the chat we have another question and a suggestion also about a book. About building a product by Tony Fidel. It's called Build. But regarding the question, David wrote that in the previous lecture, Babysteps was talking about licensing. Have you ever produced hardware that scaled up in manufacturing and sales via licensing agreements? Can you talk a bit about that?
Yeah, only actually very briefly, because again, I'm mainly the engineering side of it, so I rarely get involved in the politics of it all. I understand that it might be an approach, but I'm sorry to say I probably don't have a more useful comment on it.
Okay, thank you. I saw that previously Jans had his hand up, and I think he was ready to ask a question, but the hand disappeared. So Jans, if you have a question, this is the correct time to ask it. Okay, I guess not.
No, I can try. Sorry, I can try. Did you ever have experience with production as a product as a service, when you get back the product from a user and make some changes? And I had actually one more question, but I forgot it.
Yeah, I guess this kind of goes back to David's question in a sense. I mean, as an engineer, I usually don't deal with the how the sales part of it is solved. So yeah, sorry to say, I probably don't have a good answer. Don't have a good input on this one.
Okay, thank you. So do we have any other questions here? And we can still use the remaining minutes to have a Q&A. If not, then of course today we can finish early. Yeah, however you feel. I mean, use the opportunity to ask any questions you have in your mind. If not, then I think I'm gonna have to say a huge thank you, Kaspars, for being ready to jump in at the very last minute notice and for giving this lecture. I do hope the audience, also the participants, enjoy this, and I believe that each and everyone can take away something valuable to use in the development of their own ideas. Even though mostly you were talking about hardware, I was thinking along, and I could see the way you could also use this for software. So I see you have something to say.
I think we also have an exercise for the teams to kind of do homework,
Yes,
if you will. You know,
we do. I will quickly, because I did write something, added something to it. So yeah, the homework until usually it would be for 7 days, and it is going to be in this case 7 days as well, but usually it would be given on Monday, and you should hand it in by next Monday. In this case, since we are having this session on Wednesday, then you will have until next Monday, 5 o'clock Riga time. So I will share the document that you need to fill out in our Slack in the homework channel, but there are a couple of things that I will ask of you to do. One thing is I would like for you to give 3 examples of how do you plan to validate if your idea works. Best ways for that in your specific solution. So please come up with 3 different ways how you would go about validating your idea or if it works. Then another thing I am going to ask is in the file is to do a bit of risk analysis, as that was touched upon quite heavily today. So you will have to mention 5 possible risks and also write possible solutions to these risks. And one more thing that me and Kaspars talked about was for you to describe how you will scale your product. For hardware, what technologies will be used, whether it's business viable, what physical aspects will it have, and for software, what programming languages, platforms, engines, etc. There will be a limitation to characters to use, but this will going to be more of a free-form definition. As for the first 2 tasks, it's going to be specific examples to give. So yeah, you will have a week to talk with your team to decide upon these things. And yeah, to give the answers to me. So once more, I'd like to give a huge thanks to Kaspars for joining in and for giving this lecture. Any closing words from you, Kaspars?
no, well, I will also thank everyone for attending this lecture, and yeah, I wish you luck with your product, because luck is that one component that we all need in this. Thanks.
Amazing, thank you. And yeah, the final thing I want to mention, like I said, I will post the homework in the homework channel on Slack. But one thing that I do need to mention, if you are in Riga, if you are in Latvia, or maybe you live nearby, then TechHub is actually organizing this thing called Startup Barbecue this Friday. It's going to take place in Spīķeru Kvartāls. So if you are nearby, if you want to meet maybe fellow participants from this course, or just meet people from the startup ecosystem, Latvian ecosystem, and possibly even further international, please find the event. I will share it on Slack as well. Find the event, register to it, and go meet people, drink some beers, grill some meat. I see the tagline for the event is networking, connecting, grilling, being human, a lot of fun, and then some. So that's what you can expect from the Friday. But like I said, I will share more details on Slack. So once more, thank you to Kaspars for joining in. Thank you to everyone who was willing to join in on a Wednesday. I know we had promised Mondays, and from here on out, we will stick to Mondays. Don't worry, the calendar should not change anymore. But yeah, thank you for participating here in the live session. And of course, thanks to everyone who is watching the recording. So I guess have a great rest of the evening, and I will share the homework. And if you have any questions, you know where to reach me: Slack, email, phone, etc. And thanks to Kaspars once more. And yeah, see you next time. Goodbye.